Hi, in this video we'll be taking a look at sample problem 312. And in this problem we're told that we have a set of data whose histogram is bell-shaped and yields a mean of 50 and a standard deviation of 4. And then it's going to ask us what proportion of the observations fall within a certain range. So before we get to the specifics on that, we're going to deal with the general information, and we're going to be touching on what's called the empirical rule. So you can see up here in cell A1 that it gives information that the standard deviation can be used to compare the variability of several distributions and make a statement about the general shape of a distribution. And what happens is, if we know the histogram is bell-shaped, then we can use what's called the empirical rule. And the empirical rule, I've just stated in 1, 2, 3, in rows 5, 6, and 7. I also have this graph down here in the lower right corner of your screen. The empirical rule states that 68% of all observations fall within one standard deviation of the mean. Approximately 95% of all observations fall within 2 standard deviations of the mean, and approximately 99.7% of all observations fall within 3 standard deviations of the mean. And you can see there we've got the standard bell curve here, and it's got marked off -1 standard deviation plus 1, -2 plus 2, and then -3 plus 3. So if we know the mean is 50, the standard deviation is 4, then we're also going to know that 1 standard deviation is 4 away, 2 standard deviations is 8, because it's 4 plus 4, or 4 times 2, which however you want to think about it. And then 3 standard deviations would be 12 away. So I'm just going to create a little chart here. The 1 standard deviation, 2 standard deviation, and 3 standard deviation. And then I'm going to have the low and the high, and then the question is asking approximately what proportion of observations in case A are between 46 and 54, B between 42 and 58, and C between 38 and 62. So what proportion? Let's make that not centered. Oh wait, and I wanted all those up, excuse me, 1 row higher. So in this case, if we take the mean minus 1 standard deviation, that gives us the low for that range. And I'm going to make sure that's centered. Make sure this is centered. And we'll do that one. Left. Okay, so 1 standard deviation on the low side is 46. Again, if we take the mean plus the standard deviation, that's going to give us 54. We can do the same thing for 2 standard deviations, so it's equal to 50 minus 2 standard deviations. Oops. Let's do that again. It's equal to the mean minus 2 standard deviations. And then we've got, it's the mean plus 2 standard deviations. So the range there is 42 to 58. And then for 3 standard deviations, the mean minus 3 standard deviations, which is the mean minus 12, gives us 38, equals the mean plus 3 standard deviations, gives us 62. And you'll notice in the problem, part A here, it gives us A, so A would have 68%. B would be 95%, and C would be 99.7%. So it's pretty easy to calculate, and this problem sort of made it easy, but at least you, kind of the way I've got it laid out, you can see that as long as it's bell-shaped, that you know approximately 68% of the observations are going to be with 1 standard deviation, 95% are going to be within 2 standard deviations, and 99.7 will be within 3. That's it for problem 3.12.